Hello, everyone. Can you hear me?
I can hear you.
Excellent. Excellent. Hello, Eve. How are we? Good morning. Good, very early morning.
Good morning. Good morning, everybody.
For politeness as I drink my coffee. So it's approaching 12 o'clock. It is 12 o'clock. Shall we start? I have the slides to present, but I run a 4K monitor. So if they are too high resolution for whatever reason, can somebody please shout and we'll do something different. So let me just try and get the chair slides, which have all appeared in the wrong order. Let's see. No, they have appeared in the wrong order. Stop sharing that. Sorry, slight competence failure. There we go. Yes. So can you see my screen?
We can.
Excellent. So obviously I now can't see Meet Echo. I can only see the slides I'm sharing, but we'll make it work somehow.
Yes, and I will monitor to see if anyone is in the queue. Okay.
That would be great. And do you want to kick off, Eva, or
why don't you have a go at it?
Okay, no worries. So I'm assuming we've got everyone here. We're about 1 minute behind time, but we've got a fairly packed schedule, so I'll press on. Hello, everyone, and welcome to the RAW Working Group meeting at IETF110 virtual / pretend we're in Prague. Good morning if you're in the States. Good evening if you're in Asia. Hello, good day if you're in Europe. So as this is a working group meeting, this is covered under the note well. If this is your first time attending an IETF working group meeting, I suggest you find a copy of the note well and read it carefully. Those of you who are old timers are probably familiar with this. This is the standard note well. BCP 79 is the document which describes in great detail what this actually means. But the executive summary is that line in bold, which is you are contributing to the IETF by speaking. That's the short answer. So, and here is the various other policy documents you need to know about: anti-harassment, code of conduct. If you have any concerns about any of these things, we, the chairs, are your first port of call, and we can escalate this to the various working groups set aside specifically to cover these sort of things. So, administrivia. I'm assuming you're all on Meet Echo. Some of you might be on Jabber. Some of you might be dialed in through some audio stream and just listening, but the details are on the screen now. Key points are, Eve is currently tracking the Jabber, which is integrated into Meet Echo. So if you have comment, please, a quick chat message is great, or you can use the Meet Echo facility to join the queue, equivalent of raising your hand, and we, the chairs, will start pushing people through the queue so they can make comments at the microphone, so to speak. The other key point is we are using CodeMD for our live minutes. I'm not sure if we've got a volunteer for a minute taker yet. I can only see my screen and not Meet Echo. But we need to collaboratively produce some minutes for this meeting for posterity. So please join in the integrated CodeMD. It's Markdown. It will handle multiple people typing simultaneously. Please don't massively overwrite other sections that other people are typing in. There will be an opportunity before Meet Echo closes down at the end of the session just to quietly take out your typos and things like that. But I know at the last session, at the virtual 107, which we held, we had a bit of a cock-up with the blue sheets and we lost half the attendees list because somebody was very excitably editing or there was a glitch or something. So although it works pretty reliably, please be a little bit careful about simultaneously typing exactly the same characters as somebody else. Otherwise, the normal things are we have a mailing list. I'm sure you're all subscribed to it. The mailing list is the official place where consensus is achieved and decisions are made. So if you have a long and detailed discussion, the mailing list is the place to have it. And even I may, at certain points, as time presses on during this meeting, say, let's take that to the list, which means it's a valuable discussion, but it's consuming all of our agenda and we want to get on to some other points, and the mailing list is the right place for that. And a link to the meeting materials is at the bottom, so this should be well, it isn't, should be, it definitely is, where you can get a copy of all the presentations that are being presented, plus the chair's slides and the agenda, and the minutes should be there as well when we have got round to uploading them after this session. It normally takes us a little bit of time, thanks to time zones, to get that sorted, but the minutes will go up there for all posterity. So, agenda. I've sort of done the intro, I'm doing the intro. We're going to kick off with LDAX because Niels and the team have done lots of extra work, and we'd really like them to present what they have done so we can see where we are in terms of progressing that document. As far as I'm aware, it is getting pretty mature, but I will leave Niels to let us know what he thinks the next steps are as far as the working group is concerned. This is a working group document, so it's ours, the group, to have consensus on whether we think it's finished, not finished, ready for working group last call, etc., etc. But Niels and the author team obviously are the ones holding the pen. After that, Pascal's going to go over the changes that have happened in the raw technologies draft. So that's, for those of you unfamiliar, it's a great lengthy document which covers a lot of the link layer technologies that are out there, a lot of the things we're copying across from .NET, and sort of state of the art in terms of what we could use to build raw systems. And tacked on to the end of that, I asked Pascal if he could go over some of his what's currently a personal draft into proposed architecture for raw. So this introduces some of the concepts that have been discussed on the list in person at meetings before, introducing the concept of a path selection element, how that integrates with OAM and upstream traditional TEAS style PCE, and how that integrates downstream with TSN and various wireless technologies, etc., etc. And I thought it was useful to go over that one more time because following from that, I'm doing a short presentation on the DLEP protocol and how that might apply to RAW, how it might bring us some interesting things that we could reuse or build upon. Carlos Bernardos has some interesting use case analysis for MEC, and I have to remember what this is. It's basically edge compute use cases, and how those edge compute use cases really need some understanding of, if they're running within a RAW environment, what can RAW tell the edge compute management system and an orchestrator so that it understands the capabilities of the network as it starts to push functionality out to the edge. But obviously I'll let Carlos clarify that because I'm approximating my understanding. And we have a presentation from Ruta Sofia, I hope I pronounced your name correctly, talking about some of the industrial requirements. So there's a really nice personal draft has gone in with lots of detail about industrial wireless and the sort of things that use case would like to see coming from determinism and reliable layer, wireless layer, and how sort of what they'd like to see RAW tackle as part of their use cases. And we can have a discussion about that, on whether that gets integrated into some of the use cases documents or the technologies, or whether it lives on as its own document. And hopefully that will promote some good discussion as well. And for the last 10 minutes, we've set aside some time for discussion. We have a hard stop because this is the IETF working group meeting, so we are bounded by time. Obviously, as I said before, conversations can continue to the list ad infinitum. So, Eve, do you want to step in and go through some of the milestones? Because I feel like I'm just talking.
Sure. With the caveat that it's very early here in the United States, and I don't drink coffee. So,
Okay, tap out at any time.
okay. For those of you who've been tracking our milestones, these are the milestones we set when we set our charter. And at that point in time, we identified 4 documents that we had ambition to deliver, both as working group items for adoption, as well as eventually to submit to graduate through the process. And those are the items that you see here in boldface, a use case documents, originally what was a requirements document, but which has evolved into somewhat of a technologies document. Not somewhat, but it has evolved into alternatively a technologies document. The architecture framework document, and ultimately get to a point where we have a document that is evaluating the existence of IETF technologies and a gap analysis. And so some of these items have already been created and are wending their way through the system. We have a use cases document. Many of these have been, well, I'll say that the use cases document seems to be tracking. It's been adopted by the working group, as has the technologies draft. We have not submitted anything to the IASG as yet, but and we'll have some discussion today about the architecture framework document. And so you can see we're a little bit behind in where we meant to be, but nonetheless, there's a healthy collection of internet drafts that we believe, with some maturation, will get us to where we want to be. So I would say that, and we discussed this last time as well, that although we are somewhat behind, we seem to be making steady progress. And we will focus a little bit on, although there's no evaluation of an existing IETF technologies and gap analysis document, we feel that the other documents are steadily marching us towards that. You can advance forward, please. So this is just a preview slide of what we're hoping will happen after the presentations. But while you are listening to the presentations and hopefully participating in some of the discussion afterwards, keep in mind that some of the issues that are top of mind is whether the architecture document is ready for working group adoption. There's been some just early morning back and forth on the mailing list, which has been quite interesting. Which we will return to a discussion today. The OAM draft, is it also ready for working group adoption? And the technologies draft, should we be submitting it to the IESG? And then, as was stated earlier, we have this wonderful new detailed industrial requirements draft, whether to keep it separate or combine it, that seems top of mind. And then these other topics for which we have presentations, the MEC drafts, the DLEP draft for RAW, and just to bring to your attention, a draft that, although we decided not to schedule for this session, we anticipate including it in the next IETF, and part of why it's not here being discussed is just scheduling issues. And also that it will be presented during the second session for DetNet, which is tomorrow. And we would encourage those of you participating here today to attend there to catch that. I think that's it. Without further ado, we should head into our presentations. And I believe our first presentation is the
It's the
LDAX.
LDAX, I believe. Give me 30 seconds to find it.
Unless I think it's.
Oh yeah.
Niels?
I mean, Niels, if you want to present, that's fine, because then you can control the slides by all means. If you can't present, I can stand in if you need.
I know it'd be great if you could present them.
Well, I will share them. You present them, I'll share them.
Perfect.
Let me. For some reason, Chrome puts these entirely in a random order. I think Does that look like the right slides, and can you see
I
them?
think it does, yeah. Perfect.
Good. Okay.
Okay, yeah, it's great to be here, and today I'm going to give an update about the work that we've been doing for the last 3 months. Today I'm going to present the LDEX, the L-band Digital Aeronautical Communication System, short LDEX, and the draft version is 07. Next slide, please. Yeah, here we find the node well. Again, I think we saw that already. Next one, please. Yeah, that's the current version. So if you have not had the chance to read it yet, it's a great read, I can assure you, so please go ahead. We also received a lot of feedback, so thank you everyone for providing us with valuable input so far. And as you can see, this version is now from 17th February 2021, so rather recent. Next slide, please. Yeah, here we can see some changes that happened since the last IETF 109. So last time was all about bringing in the reliability part into the draft. So why LDEX really fits the description of the group theme here. And now this time we were asked about the security of LDEX. And so mainly we focused on chapter 10 here. So the security aspects of LDEX, what kind of security do we need here in this technology? Also, on a broader scale, we had some discussions with ICAO, so with the International Civil Aviation Organization and radio manufacturers, about the general architecture and ecosystem in which LDEX will live, because LDEX will probably be deployed starting around 2024. So a lot of things are currently shifting and moving, and it's quite the exciting time, to be honest. And so also another important update was just that basically in this draft, what we're doing is describing the data link between a ground station and an aircraft. So in previous drafts, we did describe the data link architecture between a ground station controller, controlling multiple ground stations, and then controlling multiple aircraft. And now we're only focusing on the ground station to aircraft station part. Yeah, so let's dig in. Next slide, please. Let's start off with the basic question. So why does aeronautical communications in particular need security, and what did happen over the last 30 years? I'm saying 30 years because aviation thinks in very long terms. So if you think the last digital data link for terrestrial communication that was actually adopted and specified and so on, that was VDL 2, and the first specification that defined that was in 1990. So that's roughly 30 years ago, actually. And since then, a lot has changed. So the problem that we're facing now is the changing threat landscape, because historically, the communication, navigation, surveillance, and short CNS wireless technologies, they emerged from the military, and the military has a lot more bandwidth, they have a lot more spectrum, they have a lot more resources to, for instance, use physical layer robustness measures such as frequency hopping or pilot symbol scrambling and stuff like that. So to make it robust and secure already on the physical level. And for LDEX, this is not possible because we're talking about the civil technology here, so we have less spectrum available. And then the question is also with software-defined radios. So I have some laying around here, actually. And there's a lot of open source software making them able to capture traffic or possibly even to inject data into the aeronautical data stream. And as all of this is wireless, obviously, this is quite the threat, obviously, civil aviation is currently facing. So the consequences are that future technologies, and I'm talking about LDAX as one of them, obviously, but also one that was already published, Aeromax, or then SATCOM, Iridium Sat, Certus, or Inmarsat with broadband, and all this stuff coming up for the future communication infrastructure for aeronautical comms. All of these need to have strong security features already implemented on the link layer, basically because that's the first point of contact, obviously, when you make contact with an aircraft and start communications. And so strong cybersecurity measures are a must for LDAX. That's the consequence out of it. Next slide, please. Here we have the shells and shoulds. So what should LDACs have? What shall LDACs have? Obviously, the very first requirement that's not listed here specifically is if we use security measures here. So if we put security in the system, obviously the regular working should not be hindered in any way. So we have to make sure that whatever security measures are put in, that safety is in no way endangered, obviously. So that's the availability and continuity as we know it. So for instance, packet rate limiting and stuff like that. So make sure that technology is available, but it's also make sure that whatever security you put in, that the technology itself remains available. Then one big important point is the integrity of messages in transit. So whatever is being sent on the data link needs to remain authentic and integer. So no other, for instance, no adversary should be able to put in data link on data on the data link, obviously. Also authenticity, so that means we have to have mutual authentication in the field. Then this should provide confidentiality, so that's a question of key management, basically, because obviously aviation is handled around the world. So how do you make sure that if a message is delivered in a confidential manner and some air traffic control service or some other air traffic control from another country needs to have access to this kind of information? So confidentiality is a should requirement for other sensitive, for instance, business data or stuff like that. Then the non-repudiation, this is important, obviously, for the sensitive part of the mutual authentication and key exchange part. And then there's the authorized permitted actions of users and deny actions else. So we have to have some kind of identification, authentication, authorization, and so forth. And also, LDACs needs to have some kind of capability to prevent, if there's an intrusion, and we need to prevent it to spread from there, obviously. So next slide, please. So this brings me now on how do we incorporate now security into the protocol stack of LDAC. So LDAC security is located on the link layer, you could say. So because above LDAC, so above the subnetwork protocol, the SNP, it is foreseen to use IPv6 and then above UDP. So LDAC security secures the connection between an aircraft station and a ground station, as I said before. So just the very first time, for instance, there's a plane flying around, and then there's an aircraft station broadcasting its beacon, and then the aircraft catches that beacon and sees, okay, for instance, there's some kind of a signature with a timestamp in it or something, so I know it's a valid ground station. Then it starts making basic contact, so just a cell entry process where the aircraft gets access to the LDAC resources, so the actual data link communication, user data communication, and then the entire authentication procedure actually starts. So this is why we say the security really is between aircraft and ground station. Next slide, please. So yeah, how do we put in security, and what kind of security do we actually put in? So here we have the protocol stack again. So below we have the physical layer, medium access layer, the MAC. Then we see here this DCH and DCCH and so forth. So DCH is the data channel used for user data communication. Then we have the CCCH, DCCH, the random access channel, the RACH, and the BCCH, so many channels here. So the random access channel is the one where an aircraft comes into the cell and says, hey, I'm here, I want to get access to the cell. The BCCH is basically the broadcast where a ground station announces its existence to the world. And then the common control channel, the CCCH, is for that the ground station grants resources to an aircraft, so an aircraft can actually transmit in the data channel. And the DCCH finally is the resource request channel, so to speak. And then you can see that the DLS, so the data link service here is for the user data part, and the LME, that's the LDAC management entity, is basically for maintaining the link and also, as you can see here now, handling most of the security part. And then on the SNP, so the subnetwork protocol layer, we foresee user data security. So as we see here, user plane security will be handled in the SNP. Currently, we're discussing And also ICAO has some ideas on that, AES-256 Galois counter mode would be a great idea because it provides confidentiality and integrity at the very same time. So that's a great thing. If that's not possible, then also we're considering HMAC with hash functions from the SHA-3 family or Shake. And then more interestingly, actually, is the LME now. So there will be LDAC-specific certificates, the same way as Aeromax has Aeromax-specific certificates. So Aeromax is an airport communication data link. And this LDAC is for terminal maneuvering areas and en route communication on continental flights, basically, or when an aircraft flies over continent. And so, yes, LDAC-specific certificates handles the mutual authentication. So there will be some kind of station-to-station or Sigma protocol. I'm going to come to that a bit later. So entity authentication, key negotiation, key derivation, key management, key handling, basically is the task of the LME or some part of the LME. Obviously, security logging is what we need. And because resources requests or sending beacons and stuff is also triggered by the LME, then the control channel protection in some ways also part of the LME. Next slide, please. Yeah, trust is probably the most important thing in any system. So as I said before, LDACs will follow the Aeromax lead and also use a future communication infrastructure FCI-specific PKI, also defined here in this RFC, and we'll use some X509 certificates that are very specific. So prior to the ATN IPS, so the aeronautical telecommunications network over, for instance, IP, there was way back ACARS and ACARS in 2007. They had a great update in the ARINC standard 823 with ARINC message security, and they basically predefined what kind of for what kind of certificates you will have in this ecosystem, and we will probably follow their lead and also just incorporate the updates that happened since then. Then mutual authentication and key agreement. We have unique identities for aircraft and ground stations. And we're currently going for either an identity-based station-to-station protocol or an identity-based sign and MAC, so Sigma protocol. So Sigma is part of TLS 1.3 now. So I think it's a great way to go forward. Next slide, please. Yeah, then the choice of the Diffie-Hellman, that's a good question. So what kind of Diffie-Hellman do we need? Because of the lifespan of aeronautical communications, you would think we will definitely have to go for post-quantum security. The problem with post-quantum is, so we looked into super singular isogeny Diffie-Hellman key exchanges. It requires keys of currently 2,640 bits. So if you compare that, for instance, with elliptic curve, so you have a factor of 10 in between. So the current way forward will be to use elliptic curve cryptography with 256 keys, and then with the possibility, obviously, to upgrade cipher suites to incorporate then post-quantum robust ciphers later on. And for key derivation, we're going for the hash-based message authentication code KDF, so the HKDF. Next slide, please. As I said before, user data security, AES-128 Galois counter mode or 256 Galois counter mode, or the HMAC SHA-3 should be enough for user data integrity protection, simply because data is very limited still in the spectrum. So if you apply, for instance, a 256 MAC here, a bit MAC here, that's simply too large. And the key basically is the result of this mutual authentication key agreement procedure that we discussed earlier on. So the station-to-station or Sigma, and then derived by the HKDF, and then we have the session key to use for instance, user data security. And now for control channel security, this is way more complicated because the challenge is here, they are small. I'm talking small about the random access has 56 bits, the dedicated common control channel has 83 bits. So yeah, they're small. And the other important thing is that everyone in a cell, so every aircraft in a cell, needs to be able to see what other aircraft around him or her or it, I think it's an it, receive. So they have to be able to read that. So we're talking about group keys. So we're talking about, we have an LDAC cell group keys via the one-way function trees, because they simply put the least amount of load on the link. Time-bound signatures in the broadcast channel, then a CSC plus MAC approach in the common control channel, and encryption CSC and MAC in the dedicated common control channel, simply because we don't have space. Next slide, please. Yeah, and I think I'm just in time. I made it. Thanks for listening, everyone. I'm open for questions now.
Thank you very much, Niels. That was fast. Sorry, we started slightly late and therefore compressed you. Let's hold questions because I see no one in the. Oh yes, I can't pronounce your name. I am really sorry, but go ahead, Walker.
Yeah, Wakar, that's right. Niels, maybe it has been discussed before, but can you revise what is the nature of coordination between ICAO and this draft? And so,
yes, yeah. So LDACs will be part of the future communication infrastructure, and the data link technology that is discussed for the future communication infrastructure is currently being standardized in one part in the ICAO. So LDACs has an official specification, and for instance, the ZARP, so the standards and recommended practices, were already defined for LDACs within the ICAO, and ICAO basically just covers the aeronautical part of that. So the reason why we're here is because we also need to cover the reliability part, right? And this is why we also think it's a great technology use here for the IETF. Does that answer the question?
Yes, thank you.
You're welcome.
Okay, thank you, Niels. I think we will move on to Pascal. Thank you very much. Let me stop sharing that and find Pascal's slides. If you are there, Pascal, there you go.
If you hear me, Rick, I can share if you like.
All yours. I have granted you permission. That's easier.
Right.
It means I can watch you present rather than watch the slides.
Pascal, sorry to interrupt here. I just wanted to finish my talk with one thing. So we haven't received any feedback during the last 3 weeks. So we incorporated everything, and now we would like to ask for last call, actually. So if there's any feedback, please give the feedback you want to give, and we're asking for last call.
Okay, noted, Niels. What I will do is I will make a note to say that on the list, because that's the right place to do the last call calls. I'll announce that. I think given the complexity of this subject, we will probably go for quite a number of weeks for the last call. Sometimes you say 2 weeks because everyone knows the subject, but I think people need to have a chance to read this in depth. So obviously, even I will have a discussion with you about what we think the complexity is, but I can imagine 6-8 weeks, something like that, to let people know. That means everyone else in the working group, please take a chance to read this. It's A, good work, but B, it's a working group document. So we, the group, need to be sure that we're happy with this. And when we are, we can press the button. So yeah, thank you for the reminder, Niels. Good.
Thank you very much. And thanks, Pascal.
Go on, Pascal,
Right,
all
okay.
yours.
Okay, I was fighting whether to share screen or just the app, so I shared the app, and thank you for giving me back the authorization. Okay, so I have actually 2 things to discuss. One is the RAW technology, for which we published a draft IETF 01 with some additions on the LDAC side, and then we'll go per your request, Rick, to discuss a bit on the architecture document and what just happened. So there are some news. So actually, I will send you the update of the slide for publication because of the discussion we had today on the mailing list. I changed them a little bit. So this is the technology. So why do we have this draft? We have this draft because some of the technologies that are being used by RAW are actually not usual to the IETF. So it's pretty cool for people coming to the group to have a one-stop shopping place where they can learn about the various technologies and why they can be used for the raw use cases. So we cover 4 technologies: Wi-Fi 6 and beyond, Wi-Fi 7 BE. We cover 1540 ACH, which is the radio link used by 6TISH. We cover 5G, 6G, and LDAX that Niels just discussed. And thanks, Niels and Corina, for the updates on this technology document. So what happened recently? Last time I told you that we had this simple structure for technology X, we had X1, X2, X3. And actually, Janos, when he published the 5G, he added something about deployment and spectrum, which was kind of nice, kind of sleek. So we discussed with the group whether the other technologies should align to this. And for now, only LDAX has, but I really hope that TSCH and Wi-Fi do as well, because that's a very, very interesting discussion, mostly because the spectrum that's currently used by most Wi-Fi applications is a very busy spectrum. But there are, for instance, for Wi-Fi, there are opportunities of using CBRS 3.5 or using 4.9, which is normally an emergency band used by police and firemen, etc. But could also be used for instance, amusement game if they have a delegation for it. And I know some games like Disney, for instance, can use 4.9. So that's a pretty interesting discussion. If you want to reach more determinism, more reliability, then having some capabilities to play with spectrum is important. So we have this discussion in LDAX, we have this discussion in 5G. I wish to have it in Wi-Fi, and for TSCH there is not much to say because it's just the plain sub-gig and 2.4 bands for now, maybe in the future. But so what's new? The doc was adopted. We are now 0.1. For I can say, apart from this discussion on spectrum that I just introduced, we are pretty much there. So I would like to discuss with the chairs on how to move on with asking for publication. Like I said, this was already emulated by LDAX, so only really Wi-Fi needs to do some work on that. Maybe some things change on the .11 side, so maybe there could be some little update on TSN over Wi-Fi. So that's something I'd like to see. I was wondering if we wanted to discuss a little bit about IP itself. Like for now, this is just the lower layer technologies. Do we want to stick at that, or do we want to have some notes about how we could signal stuff at the upper layer that we could feed into the lower layer? Maybe, maybe not. It's just something I was wondering. So if you want to discuss that on the mailing list. But my bottom line is I'm very happy with the content of this document. I was wondering if we want some more on the prime statement. I realized that there are documents like the one that Ruth has just we'll be discussing, which will also contain some requirements and prime statement. I'm not really clear about where that piece goes. That's another discussion for the chairs, because we see some of the prime statement in this document, kind of. We see some of it in the architecture, and we see some of it in the use cases. So do we think that it's something that you can intuit from the 3 documents, or something that should be written somewhere, like here or somewhere?
So Rick, jumping in on that point, a question to the working group, I would say, is do we actually want to pull that text out of each of these 3 documents and make a short, punchy problem statement draft? Or are we just making work for ourselves? Open question.
Or do we know what problem we solve already? It's so obvious that
it's not. Yes, but the counter argument to that would be we all understand because we are active participants in the working group. But in 5 years' time, when someone comes to this topic because they've been told they must implement RAW in some way, there is no explicit reference material to say this is the problem RAW is trying to solve. I think we need to look at what DetNet has done, because DetNet has done a really good job of this sort of thing, and take some guidance from what they've done. but perhaps a problem statement document, if it doesn't waste our effort, may have value. But let's take that one to the list. But I think that's a useful, or if we've got time at the end of the session, that's a useful discussion, I think.
Yes, and when we are on the architecture side, you will see as well what from the architecture document could actually move to a problem statement. In this one, it's really this piece, right? The piece on scheduling, it could move either to the architecture or to the problem statement. It really explains what scheduling can do for you and why it's needed, but why this text is actually left in the technology draft. It's just, it's okay there because of those technologies can be scheduled. It's also okay to move it elsewhere. For now, it's found its home there. It's just we need to reconsider this from
right.
IOB.
And I like this question because I know that we in earlier IETFs we discussed this and we punted on the issue, but you can see what's happened, which is that it's scattered about in several documents. And I like the crisp definition, frankly, of the problem statement in DetNet, and I personally believe that it would be good to emulate it.
It could be that we move this text on scheduling to the architecture, and we take the problem statement text from the architecture with some text from the use case and call that the problem statement. Let's see the other.
But we see, and there's someone in the queue.
Abdusalam. Go ahead, Abdusalam.
Yes. Do you hear me?
Yes, we do.
Okay. Regarding, I'm very interested in this draft or document. It's important, and I agree with Rick that we need to discuss the problem statement and the case, the use case for this document, because it's related to the RAW or the raw technologies. Regarding the 5G, actually, it includes technologies which are not RAW or raw technologies. So it will be nice to understand the difference between both of these technologies, or how it includes in the 5G technologies. I haven't read the document deeply, but I'm interested to get a feedback on this, because usually when the documents as a title saying raw technologies, that means it's the we can say the background for this working group. So it needs to be very, very well read and very well commented on. Thank you.
Thanks, Abdusalam.
So I asked for sharing again because I need to share a separate document for the architecture, please.
Yes.
So let me go. So like I said, I already pushed to Rick on the data tracker, the new slides for the technologies. Now this is a slide where I need to push to you as well. The first update is...
One second, we've got Carlos in the queue. Sorry, Eve. Go ahead, Carlos.
Sorry.
Hey, can you hear me?
Yeah.
Yep.
Sorry, it was just one short comment on the previous one, on the technologies one. If I remember properly, I volunteered in the past IETF, in the last IETF, to review that, and I didn't. My fault, apologies. So I saw that you were requesting some pre-working group last call reviewers, Pascal, so count on me. I'm sorry for
and Carlos, you're in good company, because I did the same, and so we are both.
Yeah, and me.
Looking to step up.
So yeah, so if we could get a slight update from the Wi-Fi side, that would be wonderful, and then we would. And if we have to eliminate this piece, which could be moved, the one on scheduling, then let's finalize the document, and then you can do your review. I mean, let's agree on exactly what move we do, and once we've done those moves, yes, let's trigger the review, please, and I will really appreciate your review, Carlos.
Okay, so what that sounds like to me is, at the last IETF we discussed, was this ready for last call? I think we still don't think it's ready, because there's questions over the problem statement, there's questions over the Wi-Fi, and I'm going to raise a question in my presentation as well. So I think we're close, but we're not there yet. That's what I'm hearing, but more comments to the list.
It doesn't mean we have to wait for the next IETF.
No.
We need to be specific on what we want to achieve, do it, and then let's trigger.
Okay.
So and now that's for the architecture. How much time? Oh, I don't have much time.
You can buy a little bit of time. We actually have more than 10 minutes spare at the end, so you're okay.
Okay. So the first change is, since today I just published 06. Very little changes, but what you can see on the mailing list. The biggest change is I invited Lou, because he kind of indicated that he would be interested, but it's not 100% sure. But since it's still this personal submission, I did that, and I hope that Lou effectively finds the time to contribute and help us here. This is a slide that is pretty much the one I presented last time. The one thing I changed on this slide is how, again, because of a requirement from Lou in his mail, he said, he said, you're describing a lot of the cross-layer integration, which we can do on TACH very specifically, and not much on what is pure IP layer. And my intention was exactly the opposite. I think we said when we chartered, etc., that we won't be focusing on one particular technology where we could do cross-layer like TACH. Otherwise, we would have done that at 6-. Rather, we want to be over the top of layer 2, and provide IP layer, generic, layer 2 independent operations. And what we want to do specifically is, so this is really this sentence that I wrote here and put on the email as well. We want to bring some more dynamics in how we do per packet control to trigger .NET services for one packet, but not necessarily the same for the next packet, which is basically this PSC engine that we define. And we also need to define the signaling that will enable the activity of this PSC engine. So that's why I added this text. Really, the intention, and now I'm checking with the group that will agree, we are doing an IP layer 2 independent technology over the top, and what we are doing is controlling how we make the .NET services layer, .NET service layer operation like replication, elimination, and we extend actually what .NET has defined with Pareo over radio networks, but we could do the same on non-radio networks because we are layer 2 independent. It's more like radio needs it. Radio brings us a lot of diversity that pure point-to-point wires won't. Let us use dynamically this diversity to combat the packet loss, which is also specific to radio.
Pascal, can I add an extra point there, which is
okay, and I can even read it on the slide.
I completely agree with you that it's about providing an IP layer across the possible layer 2 technologies. And I think going back to Abdusalam's point about the technologies draft, I think the technologies draft should probably be called underlying technologies or supporting technologies, because it discusses the layer 2 out of which we can build the layer, or on top of which we can build the layer 3. My comment is, I should probably take it to the list anyway, but Pareo, the opportunistic overhearing, that may work really well for some link layers when you can get that cross-layer communication, but I can't see in things like 802.11 or in 5G the IP layer even getting access to start turning on radios into overhearing mode. So we have to understand that Pareo is a great technique, or the overhearing part of Pareo is a great technique when it is possible from the link layer. But with some link layers, it's just not possible, but that doesn't prevent RAW. And perhaps it's just a matter of changing some of the wording slightly, and I'm happy to suggest text, which I have been before, but have failed to actually do, so I'm very sorry, and I will do better. But otherwise, I completely agree. Because this is the IETF, we have our remit is IP, not the link layer. Carry on, sorry.
I don't know if I completely agree with you, because it's the same concept of overhearing can be used. For instance, just to give you an example, in .11 OCB, where you don't have the context of a BSS, and so you are not constrained to an association of who sends and who receives. So instead of being point-to-point, because of the association which filters who can talk to whom, 11P can be multi-point to multi-point. And so you can effectively do the exact same thing.
I am sure there is link layer technology solutions per technology. I'm just very wary about producing link layer specific solutions.
Oh, yeah, exactly. The intent is absolutely no link layer specific, but overhearing doesn't have to be link layer specific.
Yeah.
It's possible it's not on a given technology, but it's not something that's specific to TSCH. No.
No, and I could imagine doing something clever with Anycast and IP tunnels and effectively producing overhearing using Anycast, which would be surreal, but conceivable.
Or broadcast. I mean, if you...
Yeah.
In 11P, you could think of all your MAC layer transmission being broadcast MAC, and only IP will decide.
Yeah. Anyway, let's move on.
Okay. But your point about renaming the draft of technologies, I love it. Let's rename it like underlying technologies or something. And then please think twice about whether this discussion on scheduling, which is really about those technologies, should stay there or not.
Okay, that's definitely because
it's
I've
an
got
underlying
Taurus in the
technology
queue.
discussion as well.
Taurus, go ahead.
Yeah, so I think this discussion was very interesting from the perspective. I would agree that there shouldn't be something for existing link layer specific technologies. On the other hand, these layer 2 tool sets that can help build a better layer 3 on top of it might be a good thing to collect and promote to the layer 2 technologies as they evolve.
Absolutely, and I see that as part of RAW's remit. So to be able to push back to the layer 2, emerging layer 2 technologies to say, hey, we can do some really cool stuff at layer 3 using the RAW framework and architecture. Please consider this as you start to up-rev your link layer to do more exciting wireless things.
Well, just make sure that it is packaged in a way that they don't have to wade through hundreds of pages they're not interested in.
Noted. Go ahead, Lou. Sorry, Pascal, you've kicked off a conversation, but that's the point.
Yeah.
That I was getting at on the list. I wrote this in Jabber. It doesn't seem like anyone's channeling that.
Sorry,
Lou. I think there's a difference between the architecture and a particular solution space framework. And what Pascal's talking about here, I think, is perfect for a particular solution space that, as Rick, you just said, is within scope of the working group. Now, that said, it's not the only solution, so it doesn't belong in the architecture document. So I really think it's you're making the case that we need to split these, where the architecture should allow for any particular solution, whether it's this heavily integrated solution or a more traditional layered solution. We want to allow for both of those, and then we can have frameworks that focuses on each of those.
Sorry, I'm jumping in. I'm in total agreement, Lou, because I think some of the architecture is great and really generic. The PSE concept, all that discussion about fast turnaround decision making as compared to the much slower turnaround PCE, that highlights the need for that control plane protocol so that the PSE can understand what it's doing. All of that is great and very generic. And then yes, for some of the fine detail about overhearing and some of the Pario techniques that may be applicable to some link layers, if given the requirements of link layers to support it, possibly brought out as we're creating more documents, but I think we're not creating more content. So I'm in favor. Go ahead, Georgios.
Do you hear me? Hello?
Yeah.
I just wanted to ask whether this framework part per technology specific, do you envision on a separate document or like subsection somewhere at the end of the architecture document? Like we have in the beginning of this architecture document, the independent layer 2 independent, and then at the end we have layer dependent, even though I'm not sure if overhearing it is
my personal opinion is, because I'm lazy, I would do it on demand. So I would include it all in one document because it's easier to work on, right up until the point where that section becomes 26 pages. And then you say, do you know what, this is a different document. And then you cut, paste, create a new document. I think we could overplan this and find we don't have people who are interested in actually doing the work.
Okay.
But
yeah, but the intention, even for overhearing, the intention was not to be specific or even integrated. The intention was to be able to signal, please pick this packet and have enough abstraction that it can be layer 2 independent. But if we can't do it, that's fine. But the goal was to make it viable, because I know at least 2 of those radios which can do it.
And it's a very useful technique to have, so it's got to be mentioned. But that's fine detail. Let's take that exact detail to the list, because I think
the intention was not to be specific to one technology. Certainly, yeah. I mean, since Lou's point at the first BOF, we kind of moved clearly towards the IP layer operation, layer 2 independent, blah blah blah. Okay, so the architecture itself basically describes 3 steps. We need to learn about, and it's a loop, right? It's a permanent feedback loop where we learn from OEM. We make a forwarding decision for the packet, which is done with this new PSC entity that we have defined, path selection engine. And then we take action, and the action may be done on the same node where the PSC has run, or it can be done on a different node. For instance, the PSC could just act at ingress, like there is a full feedback loop from the path through the egress back to the ingress. So the ingress knows how the previous packets have fared. And so it can make decision for the next packet. In that model, it would basically signal something in the packet, like segment routing or something, which would affect, just control the DetNet service layer in, for instance, replication on node D in this picture. It could also be that the PSC is distributed, which means that every node would actually think about what to do with this packet based on the rest of the way. In which case, the kind of signaling that you would find in the packet would be more of a hint. The ingress hints, like, I want to get this level of quality, and I'm distributing this load or the statistics to get there to different nodes, and they have to act on it to reach kind of a goal that they're given, something more abstract, so that the PSC, which would be distributed, would have to think about what to do to achieve what's being asked. So that's what I mean by a raw service 6 to hint or control the DetNet service layer here. Yes, there's an extreme point where the PSC is fully distributed, meaning that every node is aware of the OAM, and the packet just contains the information about the flow, like pure DetNet information, without any SR v6 type signaling, which would indicate the decision done somewhere else or the hint from somewhere else. And so each node, A, B, C, D on this path, would have to make its own full decision based on the rest of the way. So right now, the architecture allows all those models. Just like in the DetNet architecture, we allowed a number of models, but then we said, hey, we're going to go for this. So here at some point, even if we describe all those models, if we decide to move on with doing something, we'll have to discuss exactly how. For instance, do we really want to do this fully distributed thing, which can be hard. And then so the DetNet service layer, why did I write plane here? It's in network plane, but it's called service layer, sublayer, whatever. So in the DetNet service layer, we have actually enriched it. So part of that is those parallel functions that we have discussed. There is all the timing discussion, which is the presentation that Yakov will be doing tomorrow at DetNet. And there are all the kind of hints and control that we could tag from the ingress in the packets. So the rest of the way can make just forwarding actions or some more PSC level determination. So whether it's a hint and then you have a distributed PSC, or pure control. And then in the intermediate node, all you need to have is a service layer which understands that control. So that's pretty much what we want to describe very abstractly in the architecture. As it goes, we've done a lot more than that because we don't have framework documents and we don't have prime statement documents. So we can have 3 parts. One of them is read a prime statement. So it was much needed because we don't even have a terminology without it. So we define the terminology. We define what we mean by reliable and available. That was a huge discussion at the BOF. And we actually decided to base those definitions on what NASA actually uses for the space shuttle. So it's, whatever happened to the space shuttle, the definition looked good. Then, yeah, and then use case and requirements served. Here we are not dealing with specific use cases like amusement parks or industrial blah blah. What we mean is really use case in terms of single hop, multiple access, or more like single technology, multiple hops, basically. So that's why we have this 2.3.1 radio access protection, in which we discuss the first picture here. So we discuss, this model where you could have, for instance, 5G and Wi-Fi, and the PSC will decide whether to use 5G, Wi-Fi, or both. It's just an example. But it shows that if you can already do it within 5G, you are going to be able to do it with Wi-Fi 7 as well inside the technology. But it would probably provide even better diversity, so better reliability, if you can do it across technologies. And that's why going to layer 3 is actually a good idea. So that's what we mean in this section 2.3.1, radio access protection. And then 2.3.2 is the discussion on the wireless mesh. And for this, the 2 examples are Wi-Fi mesh and TSCH mesh, for which we want to provide end-to-end reliability and availability by using multiple paths, basically, and diversity and across all, space diversity, time diversity, coding diversity, all the parallel functions, blah. So yes, we have still a prime statement, a framework, and an architecture piece. What we don't have right now is discussion on not only the where to forward to, but the when to forward, which is really something that Yakov's document hints us. And effectively, it makes a lot of sense to signal that as well as part of the hints that for instance, the head end, the ingress could signal. It could effectively signal what's the expected schedule for this packet. So the packet would know if it's ahead of schedule or below, in which case it needs to be accelerated.
So Pascal, can I just jump in very quickly there? There's some very similar work that's happening in, you've got a lot of feedback. There's some similar work that's happening in the DTN working group, which has actually come out of the delay tolerant deep space work, where they have this concept called contact graph routing, where your forwarding information base is augmented with contact times. So they can know when an expected adjacency is going to form. Oh. So it's effectively timetabled. It works well in deep space because you know where your probes are, and we're talking minutes and hours. But some of the theoretical work they've put into making sure that is actually watertight and mathematically sound could be reused, a useful reference point. I'll try and send you some URLs and
if you could put something on the mailing list, Rick, that would be excellent. I was also wondering, when you've got those constellations of satellites and they kind of cross, in the sky.
Yeah, that's all planned, and you know when it is.
And they know exactly when the link comes up, when the link goes down.
Yeah.
Now, the thing is with those radios we're talking about, it's more dealing with uncertainty than dealing with certainty. Like they are certain that the link will come up at this time and that it will go away at this other time. We are completely uncertain that the next packet will fly through on this link. So we actually leverage blindly a lot of diversity to cope with the unknowns that cause this loss. Mm-hmm. So there is a link between the two. I don't know how far it can go. Or
it's the double negative. It's the moment where you know there is no contact at this time. So there's no point even attempting to send. So it's pruning redundant leaves from your tree is the point.
So yes,
anyway,
there is something common. I just wonder how far we want to take this architecture. But I can see why this intuition you have in mind. I can see how interesting it is. It's really interesting. Okay. So there was the discussion of splitting architecture framework on the mailing list with Lou. And then we just said maybe splitting prime. Actually, that's kind of what I did when I restructured 405, which is I basically put together the first sections on prime, then next section on framework, as you can see, section 3 and section 4 on architecture. I'm not 100% sure how, I mean, you still need to be able to read something in the right order, so you don't have to go back and forth between things. If you have 3 documents, how can we make sure people read them in the right order and don't have to go across all documents? That might be a bit tricky. And then I was just wondering if you guys think we have a path to adoption and what needs to be done on the path to adoption.
So on that note, we have a milestone to produce a document of this sort. I can't remember exactly what the charter calls it, but I think it calls it an architectural framework or something like that. So we have a charter item to get this done. And I think it makes sense prior to working on, and I know the ADs agree on this, prior to working on actual implementations, we need to have a clear idea of what we're building, how we're building it, and why we're building it. So that's the problem statement, the analysis of the technologies, and a general architecture. So yeah, I think a document, some part of this document, whether it gets split or whether it exists as one, will ought to be adopted by the working group.
And it looks like we have
We've lost
also in the queue.
Oh, go ahead, Abdusalam.
Thank you. My comment is regarding this document. Actually, I want to read this document and give comments on it or adopt. I need to make sure I read the requirements and use cases documents. So I was expecting to listen to the requirements documents first, which was in the end of the agenda today. But usually this document, in my opinion, is the architecture should be considered or looked at or indeed after we decide the requirements for the, as one document says, the requirements for the industry, and the other is use cases, which has the same author, Mr. Pascal. And I thank Mr. Pascal very much for his participation in more than one document, actually. Thank you very much. Thanks, Mike.
I agree, Abdusalam, and the working group is currently reorganizing the content it has. So we've pulled the use cases out into a document which sort of captures requirements. The intention of the working group is not to produce a formal requirements document, but to describe the problem space, which may be this problem statement document, or the problem statement may be enclosed in another document, to describe the use cases which is driving the work. And yes, you're right. The structure is not entirely clear yet. None of these documents are a working group last call. None of them are ready for publication, and we are still massaging the ordering and how they are held together. But you make a very valid point, so I agree. So Pascal, is that everything? Because I'm watching the clock, and I think that's covered all the time.
For me, yes. I mean, we were taking questions already. I'm done with my slides, and I will send you push the updates on.
Thank you.
Data tracker.
Excellent, and then we can come back to this at the end. We've got a bit of open mic time at the end, so we can certainly discuss as a working group where we think we are in terms of the various things that get presented following that, which is why I thought it was relevant to have a bit longer on that piece. Eve, do you have a comment?
Except that we probably need to stick to our schedule a little bit.
I'll go fast on my presentation.
Well, we have the room. Just that was a great discussion and totally worth it.
Yeah. But you're right. I'm watching the clock on this one. So I'll jump straight on to my fairly quick presentation on DLEP and what it means for the RAW working group. Can you see those slides? Eve, anyone?
I said yes.
Yes.
Ah, thank you. You're breaking up a little bit, Eve. Sorry.
Okay.
Okay, so what is DLEP? So DLEP is the Dynamic Link Exchange Protocol. It is defined in RFC 8175, and that is a standards track RFC. So this is a standard. This isn't an informational or experimental. It was developed in mobile ad hoc networks in the MANE working group, but we believe it has applicability outside of that working group. It was originally developed as a building block to solve problems within the MANE remit, but having built it, its uses, I think, go much further, particularly of interest to RAW. So I'm going to run through a very quick overview of what DLEP is and what it does, and then get on to where I think it ties into the work we're looking at within this working group and how it might be able to help us. So at the simplest level, DLEP is it's a monitoring protocol that runs, I'm pretty much reading the slides and I apologize. So it's a monitoring protocol that runs between a routing layer 3 device and its locally attached link layer wireless device, in the terminology referred to as a modem, and it allows that modem to say, hey, I'm doing stuff at link layer, I'm discovering terminals as they come online, I'm monitoring the links, I'm running my own control plane, but here is the information I know, so you, the router, can do cleverer things because I'm giving you understanding of what the link layer is doing. So there's a critical component to this, which is it isn't an over-the-air protocol. DLEP does not run over the wireless medium. It's simply a monitoring protocol that runs between the router over probably an Ethernet cable to the LAN side, effectively, of the modem. So instead of having to rely on SNMP or netconf and polling the box to say, what terminals can you see, what's your signal to noise ratio, whatever, it's a live protocol which allows the modem to have a richer conversation with the router about the state of the wireless network. Since it was published in 2019, and since then it's got good adoption within the radio and network vendors. So your usual router guys have implementations, most of them. I don't think Juniper does, but I'm sure someone will correct me. A lot of the radio manufacturers, the big guys, particularly in the defense markets, are implementing DLEP on most of their radios, and that is mostly driven by the latest tranche of large government contracts that are, particularly in the US and the EU, are starting to specify DLEP as part of their procurement for radio and future combat radio systems, simply because it's an open standard and it allows these large agencies to avoid vendor lock-in. So they can avoid buying a big vertical solution from one of your well-known vendors, and they can start to cherry-pick radios and routers from people who make really good routers and people who make really good radios, rather than people who target the defense industry. So from a customer perspective, they like it, and it seems to work for them, and it's an okay technology. I mean, disclaimer, I'm one of the authors of DLEP, so I think it's good, obviously. So what does DLEP actually provide? Really, it gives you two things. It gives you reachability information. So when a new radio device comes on channel, your local modem will tell its attached router and say, hey, a new terminal's come online. If you send me Ethernet frames, they'll pop out at the other end because I've told you I can do that. So you don't need to go and do RPing or pinging or polling or any sort of OAM IPPM style stuff to work out if someone is on the other end, the link layer has already discovered it because it's done all its link layer channel frequency stuff that it does. It's already worked it out. So you get an event to say that destination is now there. And these destinations are logical. It's not just there's another router over there with its MAC address. You can also talk about multicast groups as well as logical destinations. So, hey, a number of devices within this radio net are all using this multicast group. Are you interested in that?
Raising your hand, did you want to jump in and comment? No?
Nope.
Okay.
I'll crack on. The other bit of information.
Sorry, I was muted on the hardware. Rick, I'm sorry, but to the previous point, you were describing DLIP as operating between the router and the modem over this Ethernet, which is, yes, as I remember, the original use case. But I've seen RFC, which I found critically important, where it could actually be over something logical, like over a tunnel. The one where you describe an ID, which is not a MAC address. Do you intend to discuss it? Because I think it's kind of fundamental for what we want to do here.
Yes, I can touch on that at the end. I've intentionally kept this fairly simple and fairly to the point, but at the basic level, it's a simple IP connection. The protocol runs over TCP. It's that simple. My point was this is not an over-the-air OAM protocol.
Oh, yeah.
So the session terminates at the local wireless device. It isn't.
It can be the observer, the router could actually be a remote. Like if I have this mesh in front of me and this graph that I described, I could call every damn router along the way and ask them to tell me what they see.
No, it actually prohibits that behavior.
Okay.
It uses GTSM to enforce one hop for the DLEP session. If you wish to communicate with remote modems that are multiple hops away, you need to go and use another protocol. It's not designed for that.
Okay.
And we did that intentionally because that's the wrong way to think about what DLEP is for. DLEP is designed to do one thing only, which is give you local information about your local device. If you wish to build a big picture, go use another protocol. DLEP is an input to that protocol. It is not the solution at that layer.
But we could have some aggregating protocol that could get information from every hop and bring that back to the index.
Yeah, that's slide 8. I'll come to that on slide 8. But absolutely, this is just a building block for those systems. Classic IETF, we tried to keep it simple so we could get an actual RFC without boiling the ocean for 10 years. So as well as reachability information, DLEP will also allow a modem to communicate to its locally attached router and say what is the capability of these logical links between modems. So I can see node A, can see node B, and I can tell you what the bandwidth over that link is. I can tell you what the latency over that link is. I can tell you what the theoretical maximum given the negotiated protocol parameters we're using. And there's some other information such as the MTU, quite useful for working out how big your packets can be, obviously, and some other things such as the resource consumption and relative link quality, which are a little bit heuristic and a bit estimated, haven't actually resulted in particularly useful metrics when implemented, but that's an aside.
Lou, did you want to comment on that?
I'm actually going to comment in response to Pascal's question or comment. Excuse me. So DLEP is really like LMP or link management protocol in the optical space that came out of the CCAMP work. And in that environment, the solution does exactly what Pascal says, is it collects information from LMP, and then that information can be passed around through GMPLS TE extensions. So like when I sent on the list, we can leverage what's been done in the past with PCE and Ts. This is exactly what I'm talking about, is that exact approach, Pascal, that you were asking about has actually been implemented but albeit for different technologies.
And I would love to see this presentation from you, Lou, talking about CCAMP and LTP, because I think you could pretty much cut and paste the word DLEP.
LMP, Link Management
LMP,
Protocol.
sorry, LMP.
And you know, that was a niche protocol. Most of those have gone away with that came from the days when optical line systems or OLSs were separate. Now they're integrated into the routers with integrated photonics or tunable optics. But it's the same principle. How about instead of I put the presentation together, I'll put it into the architecture document with Pascal. Even
better. Okay, so I'll keep going on this one just to keep quick. So key points. DLEP is dynamic. I think it's worth reiterating this. Yes, you could probably just use a standard management protocol such as SNMP or netconf to poll the status of your modem and get the metrics that the modem is already recording for its own management and monitoring purposes. However, DLEP being session-based allows an event-driven model. So the modem can, as these events occur at the link layer, can signal back to the router to say, hey, that logical link I've told you about earlier, the characteristics of that link have now changed. You might want to react. It's a more efficient way of implementing. It also focuses the protocol to talk about a known standardized set of metrics in known standardized terms, rather than relying on every radio implementing the same MIB or Yang model or whatever. So that's the third bullet on this page, which is the link capabilities we define them in terms that make sense to a router. So a lot of the radios out there, they're developed by very smart people who know an awful lot about radio technologies, and their life revolves around signal to noise ratios, symbol rates, bit error rates, and all this crazy physics stuff that I didn't study at university. And translating that into something a router can make sense of is not obvious if your background is networking. But the DLEP protocol specifies that your implementation will talk about these things in terms that a router can understand, and a poor network engineer such as myself can immediately take and do clever IP stuff with. So it acts as an abstraction layer in terms of forcing the radio vendors to convert their data into information that is meaningful at layer 3. And that it seems quite subtle and pedantic, but it is incredibly useful when you're trying to integrate heterogeneous radio systems from many different vendors into contiguous layer 3 paths across a network. So going back to Pascal's point about taking packets and duplicating across 5G and 802.11 Wi-Fi 7, this gives you a mechanism where both link layers are starting to report their capabilities and characteristics in consistent metrics. So you can now compare radio mesh A's values to radio mesh B's values because they are both agreed on what those values mean. It's really handy for an implementation detail. Okay, so DLEP is also extensible. So the RFC 8175 describes the DLEP core protocol, which includes the extension mechanism. The core protocol is the general protocol session establishment, security, announcement, discovery, all that good stuff. And then the actual capabilities and information, it defines a small common subset and a mechanism to say, hey, I do this extra standardized extension, and it describes how one standardizes them through the IETF, or it's possible for other SDOs to do it. This is IANA's bread and butter. So extensions can be introduced after the release of 8175 without having to produce DLEP v2, DLEP v3, DLEP v4, etc. So there's a bunch of extensions that are being worked on. Currently, DLEP is worked on in the MANE working group, which will be meeting on Friday for those of you who want a deeper dive into working on DLEP extensions. There is going to be a big discussion there, including Lou and myself. Some of the extensions that are going on at the moment, so there's a layer 3 extension. So when you're, and this touches a little bit on what Pascal was mentioning, you can treat a a set of layer 3 tunnels, such as an NBMA VPN network, where you're building IPsec tunnels in a sort of SD-WAN solution. You can model that as a wireless network, and DLEP is applicable at that, but it needs a bit of handling, and there's an extension to make it work in that model. There is also another extension to allow you to talk about credit-based flow control, so you can rate limit the amount of data you're battering your wireless network with. It gives the modem the ability to push back against the router and say, hey, slow down, my radio medium just cannot handle that gigabit of data you're chucking at me. There's also some interesting work which is actually Lou is working on, which is to do with, instead of just talking about the logical link between different destinations, but to subdivide that logical link into different traffic classes and flows, and to talk about, so if you've got a radio that does some clever things with priority-based queuing, you can specify some traffic flows have better latency or lower latency than other traffic flows. This starts to become of interest to RAW, so you could have a DetNet style traffic classification where you have the time-sensitive data and the best effort data. And then your DLEP capable modem could say, this TSN style time-sensitive data has the following properties, but my best effort is currently running at about this rate because that's how much spare time I have in my channel allocation or my TDMA cycles or whatever. There's an extension coming out to actually reflect some of the basic radio properties. This is more interesting in MANA than I think in RAW, but it's coming out. And there's some work which I'm still trying to get sorted about a number of things such as PIM for multicast. There's the concept of rendezvous point selection. It makes very little sense to elect a node in a mesh network by a leader election using node ID and picking the lowest mathematical number if the link layer, if you select your rendezvous point without an understanding of the topology that the link layer is building, you can choose a very bad rendezvous point very easily. But I'll go into a lot more of that information in MANA. So this is the important point. Why is this useful to RAW? So in the RAW architecture, if you distill it down to the novel things that Pascal is introducing, the concept of a path selection element is really very interesting. That's the logical entity that understands the plan that has come down from the path computation element in terms of this track and this track and this track, where a track is the deterministic flow, and the path selection element's job is to understand what the wireless system is doing and try and apply that policy to the forwarding of packets in order to meet the demands of that policy. So unless the underlying link layer network does TSN already, and if it does, that's great. You can say, hey, low-level IEEE TSN or 5G or whatever, go do your thing, because I know you will support it, and therefore I can agree with the constraints that are applied on me as the path selection element. If it doesn't, the path selection element has to understand what the wireless medium is currently capable of in order to work out what to do in order to maintain those deterministic conditions. And DLEP can provide a generic mechanism to do that. So implementations currently exist using DLEP to provide stability in MANAs. So again, it's using that pushback from the modem to understand what's actually happening in the radio environment in order to provide stability in these really ad hoc networks. That same mechanism can be reused to provide determinism in much more controlled environments. So factory floor or amusement parks, or, these aren't MANAs, but they are definitely wireless, and they still suffer from interference and atmospherics and all this kind of thing. So the links wobble, but not too badly. So DLEP gives that real-time control loop back to the PSE, so the PSE can use that information in order to make the smart deterministic decisions. And that's my pitch for why DLEP works for RAW. Last slide. nearly last slide. There's DLAP has a dirty little secret, which is the link characteristics request, which is an unused or underused function, which allows a router to make a request back to the modem to say, I know this logical link is only running a 14 megabits and has 200 milliseconds of latency on it. I'd really like it to be 100 milliseconds, and I really want a bit more bandwidth. And the modem has an opportunity to try and apply that using whatever link layer technology it has available, or to refuse it. It can say, you're not allowed to do that for policy, or physics won't allow us to do that because we're in a tunnel, or whatever. But this could be a useful mechanism in a raw context for the path selection element to say, I'm being requested to pin down a track with these criteria. Hey, modem, can you do this? So this is something I think that's worth exploring, but again, I think probably take that offline and have an extended discussion if needed. So, next steps. Does this discussion of DLAP need to be included in the technologies draft? So this isn't a link layer technology, this is an IETF protocol, but it does add potentially to the raw toolbox. Does this live in the technologies draft? Does it live in the problem statement? I know Pascal's architecture draft has a section called existing IETF work. Does it exist there? Do we even want this documented? Or do we say, there's an RFC, it's an IETF thing, we're the IETF, go look it up. My other question is, do we see any raw requirements that might require an extension to DLAP to be written? So are there things that a PSE would like to use the DLAP protocol to do that are currently not in the scope of DLAP? So is there some way that would we like to write a DLAP extension which allows a radio system to say, hey, I have a TSN capability and it is described as blah, blah, blah. That would be a very obvious DLAP extension. So a raw capable routing network device would be able to talk to an attached modem over a DLAP protocol, and over that protocol it would learn that, hey, that radio I'm attached to has a TSN function. So great, let's use that and let the radio go do the TSN stuff, meaning the PSE doesn't have to worry too much about all the Perio functions because the link layer's doing it, which is great. Anyway, that's it.
We have a couple of folks in the queue. We are
Go for it.
running short on time, so I would ask them to be very concise. And Carlos, I know you're next in the speaking queue for the presentations. So particularly if you could ask your question quickly, that'd be great.
Sorry.
Yeah, sure. Very good question. I'm familiar with DLAP, so my question may make no sense. So apologies for that. But what is about? I'm wondering about the use of DLAP for OIM in general. I don't know if in MANE something was done, but applicability in RAW, I think that could be useful as well.
It's something, it hasn't been addressed in MANE. It's something I obviously see. I think working with some of the OAM, IPPM link sensing, hop by hop stuff as compared to the path stuff, I think it definitely has a part to play. So instead of having to run OAM end to end, you may find some segments within that path may be DLAP capable, and you might be able to effectively spoof the OAM IPPM style probes across that link. Very interesting. I don't know whether the RAW working group is the right place. Maybe bring it to MANE. Maybe we can take it on somewhere else. But yeah, very happy to talk about that. Lou may have an opinion on this as well. So yeah.
Okay, thanks.
And Carlos, if you could.
Yeah, I think this is DLAP is just one example of exchanging between the layer 3 device and the underlying layer 2, right? So if I think the working group wants to be architecturally clean, there should be a protocol independent definition of the information that for RAW is of interest to be exchanged, and then an instance of that can be done with DLAP. But if architectural clarity, and that's exactly the tool set we were talking in before about, right? And if you folks don't want to do that in a clean fashion, then just hack everything into DLAP. Yeah.
Yeah, so my comeback on that is I completely agree. And actually, DetNet has done a pretty good job of defining latency and maximum latency. I can't remember the RFC or the draft that it's in, but starting to define...
But it's also not very much abstracting from, let's say, only TSN as the only known, subnet technology that provides functionality, right? So that abstraction doesn't really exist so far.
Yeah, sorry, when I used the word TSN, I was just... I'd stolen the acronym to mean some kind of layer 2 which does time-sensitive networking rather than the explicit IEEE TSN implementation. I meant some sort of a deterministic layer 2, sorry. But yes, I agree. There is... DLAP is an example of something that should probably be more generic and possibly be inheriting metrics through from DetNet, because I can see people building very big networks where a lot of it is traditional wired DetNet with raw segments within it. As soon as we build raw-based industrial networks, someone is going to want to deterministically connect them together nationally.
Well, but DetNet is by now from the service fairly limited, and I think that RAW is a lot more, dynamic with respect to bandwidth, even with respect to, probabilistically defined latency as opposed to only, 100% bounded. So I'd be careful in RAW to constrain yourself to only what is currently within scope of DetNet.
Agreed. There's a feedback loop with DetNet. So the RAW chairs meet with the DetNet chairs every 2 weeks, and I see quite a healthy feedback, and Lou is about to jump in and contradict me. But, yeah, we see that as we can kind of push back into DetNet and say, you've got to think bigger because we're thinking bigger and we're very much part of the deterministic family. So, yeah.
I would like to be considerate of the amount of time for our last couple of speakers.
Stop.
So I would like to cut the queue and take some of the questions to the mailing list and or the chat window.
Right.
Carlos.
I shall stop sharing. Go ahead, Carlos. All yours.
Okay, I hope you can see the slides and hear me well.
We can.
Okay, thanks. I'll try to be brief to allow for having time for the next speaker. So this is just a couple of topics to discuss. One is on the raw use cases, just a short update on the document. So as you know, we have the different use cases covered in this document. They are listed there on the slide. And for each of the use cases, basically, we follow the following structure so far. We describe the use case, the specifics, the challenges, the need for wireless, and then the requirements for RAW. And this leads to the next and important slide, the one that I wanted to discuss today. That is, on the one hand, well, there have been not many updates since last IETF cycle, and I take the blame for that. I apologize. I'll try to do more or update the content for the next before the next IETF. And for that, one thing I need is, of course, input from the working group. Remember that this document is for the working group now, so I'm just trying to get the consensus and put that in the document. So please provide input. But in addition to this, one thing that we discussed last time is that we have to collaborate and align a bit the terminology with the raw architecture one, the document. So I will be in contact with the guys working on the other or editing the other document to ensure that. And another thing that we must ensure based on the agreement that we had in the last IETF is that this use cases document is basically also including the requirements. That's something that was discussed and agreed last time. So we have a section for that, but we need to ensure that we are properly doing the job of incorporating or covering the requirements part in this document. And then related to this, there is the discussion about the draft that is going to be presented next, that I think is a very interesting document that is specific on the requirements for industrial kind of use case or scenario. And there's been some discussion on the mailing list whether we should incorporate either a compressed version of those requirements in the use case, since we have requirements in the use case document, or to merge, or to not to do anything, or do any other thing. I'm perfectly fine, of course, with any decision that we take. I'm probably more inclined to the option that Pascal suggested about including a compressed version by leaving the other document live and be published as an independent document with all full details. But I think for the consistency of the use cases and requirement document, we need to include some part of a compressed version of it in the use cases. But this is the main question I have for the working group, to trigger this now and of course do it on the mailing list, whether you think we should include a compressed version, merge with the other one, or do nothing, or any other approach that you may have. And I would like to stop here for this particular part, and then I will go into the second part of my presentation.
So, Carlos, I've taken a note that the chairs will ask on the list exactly that question, just to kick off that discussion. Okay.
Okay. Perfect. Thank you very much. Okay. So if there are no questions with this related to use cases, then let me move into the second part, that is individual submissions about RAW and MEC, multi-access edge computing, as Rick introduced in the presentation, or in the share slides at the beginning. So I will not go into the details. This is just more to trigger discussion, or to gather whether there is interest in this kind of work in the RAW working group. We have a couple of contributions so far. Basically, the scope, or the aim of this is to explore the integration of RAW and edge computing. And we are adopting, or we are taking as baseline, the ETSI MEC architecture as baseline, because it's one that is being standardized. And as I will try to go into a bit more details in the next slide, we believe that there are use cases, as also documented in the use cases document, that justify this kind of integration of RAW and edge computing. And there may be things to consider both at the IETF side and the ETSI, in this case for MEC side, to do this integration. And the idea will be whether to explore the IETF side of those things in IETF or not. So there are two documents so far. The first one, that is the draft Bernardo's RAW MEC, that is about extension to enable this integration, or the use of RAW technologies in a MEC environment, MEC deployment. And then the second one, which is about a more specific point, that is how to enable the terminal to do the selection of in which MEC host, in which server at the edge to deploy an application, and configure the RAW network connecting that at the same time. That is a more specific thing, and I will basically focus on the first one in the presentation today. So the first document, the scope is, as I mentioned, to integrate RAW and MEC. And we justify in the document that there are some scenarios, for example, Industry 4.0, considering 5G and the ultra-low reliable and low latency communications feature of 5G. So the idea we have in mind is that we have a network with RAW-enabled nodes, and MEC edge platform, edge point of presence, whatever you want to call it, in ETSI MEC will be MEC platforms are collocated or attached to these RAW nodes that are, of course, connected via multi-hop wireless. And the idea is that in this scenario, we, of course, want to enable low latency to applications. And we may have multiple MEC platforms, and we may have applications that may need to migrate from one platform to another platform. And those are connected wirelessly, and this is where RAW gets into the picture, because by using a RAW technology or RAW deployment, we will be able to ensure the RAW requirements that the MEC applications requires, not only from the beginning, when you instantiate from the beginning, or at the beginning the application, but also when you need to migrate an application due to whatever change in the network. So that is basically the starting point, and this is the simple scenario that we have in mind. With that in mind, we started working into a potential solution, but this is just more for food for thoughts in terms of whether this makes sense or not. By adding a RAW specific entity in the MEC platform, that is what we call RAW controller, that is basically the one computing what needs to be done or to be requested to the RAW PC on the IETF RAW side of things to enable and to configure the network between the RAW nodes in order to guarantee the requirements of the MEC application. So that's the idea. And then we introduce some new semantics on the interface at the ETSI side of things between the MEC platform and this raw PCE to convey the request and synchronize on the status, topology of the raw network, and enable to configure this in near real time or real time. The draft includes procedures for doing things like initial MEC application request when we have an application and we want to deploy the application, ensuring the characteristics for that traffic flow, how to do this and how to interact with the raw PCE and do things. And then two procedures that are interesting from the OIAM side. One is when we have raw OIAM triggering or informing about a change in the raw network that may have an impact on the MEC application, and that may trigger, for example, a migration from a MEC, from an edge server to another one, how to integrate this. That makes sense in a scenario like this. And the other way around, that is to use the information that MEC OIAM may be collecting also to influence on the raw configuration, on how to update the raw configuration on the raw network. So we have these three procedures so far described there with a potential solution, but this, as I mentioned, is more food for thought and to see whether this is interesting in the working group.
Carlos?
And then we have the other one. I will not go.
Carlos?
Yes.
Do you think you could wrap up?
Yes, this is the last
next minute.
The last slide, or the 1 minute. So what I wanted to say is that this another document is about a more specific point. I will not go into the details because my main point is about the scenario, not about the solutions yet. And then the summary or the wrap-up is whether the question will be whether the working group thinks that there is interest in exploring this kind of use cases and integration of technologies, and to ask for feedback on the mailing list. That's it from my side.
Rick, I think you're on mute, or we're not hearing your audio, but you look like you're speaking.
I'm speaking on mute. It's typical, isn't it? Carlos, thank you. Sorry to cut you short. That was me talking far too long in my presentation.
No problem.
I think this is really interesting work. I think it's a little early to work on detail, but as a use case for how we want to use what we're trying to do in RAW, I think it's really important. The ability to, if we build interesting raw networks that apply this determinism, the ability to export that information out to systems that use it and to take feedback from those sort of consumer systems, whether it's edge compute, be it whatever, vital, really useful. So I support this. I'm not sure how much work we can do on this yet, but I think it's really useful. And thank you for that.
Thanks.
So it's Ruta, isn't it? Excellent. I'm sure I'm not pronouncing your name right.
I think you're pronouncing my name right. So
thank you.
I'd like to share. So my name is Ruth, like Ruth in English.
Yeah.
Okay, so I think you're seeing my slides, right?
Yes.
Okay.
We are.
So, thanks. So first of all, Rinkadev, thanks for the last minute acceptance on this, okay? And basically just to give a quick overview, because I think there is a confusion, okay, which I'd like to clarify. So in terms, when we did this draft, so me, Matthias and Paulo, what we felt, and we did look into the use cases draft, was that we needed some information about current, let's say, services that are being or could be supported by wireless. So the idea was actually, okay, we are having wireless being integrated into industrial environments, manufacturing. That's where I'm looking mostly, but the other colleagues are looking into the other scenarios. And we have different flavors of wireless that we spoke about today that are important for RAW. But the fact is that we didn't have really a concrete measure in terms of requirements. Sure, everybody speaks about bounded latency, but that was mostly it. And so in our case, okay, the motivation was, okay, we know that the wireless infrastructure is going to be integrated, of course, into the overall infrastructure that we have. This means right now interconnected to 5G, a 5G core, or interconnected to Ethernet with TSNs. And therefore, let's say our boundaries were, okay, which requirements can we have? How can we collect these requirements in different services so that what we built on wireless, on deterministic wireless, really meets what we have on the wired part. And so in terms of the structure, what we created was we gathered from different sources, looked into current services. So meaning we also looked into use cases, but we actually went to the services itself. So there's a distinction between a use case and the service. And basically we collected around 30 services. We grouped them into different categories with concrete communication KPIs. So latency, sure, but others. And then we said, okay, so that's basically what we have today. What is going to happen? Then discussing, okay, and this is more a point of view sort of individual from the authors.
Ruth?
What's next?
Ruth?
Yes.
We're wondering whether you're displaying what you're speaking to, and if you could make this bigger, that would be great.
Can you go to presentation mode would be great, because it's quite small on the screen.
Yeah, and so we did not see your slide too. Yeah, as well.
Okay.
And could you go into presentation mode? Will that work with this tool for you?
3, 2, 1.
So I'm trying to share the screen again.
I have to click and...
So can you now see the slide larger?
Can you try the presentation mode in PowerPoint? At the bottom.
In presentation mode.
No, we don't see it in presentation mode.
Okay, so Rick, do you want to share this?
Yeah, I'll share.
Okay.
I'll share. That's fine.
Thank you.
No trouble. Yeah, no, that's fine. Let me find the right window. Share. Yes. There we go. Is that good?
Yes. So let's then go to the
slide 2. This one.
Slide 3. Yes. Okay. No, actually, the next one. Sorry. Okay. So basically, the structure is still quite simple. No. Prior. Sorry, Rick. Prior slide 3.
There we are.
Slide 3. Okay. So basically, it's quite simple, as said. So basically, we collected services that run or where wireless, in this case, is really short-range wireless is mentioned, okay? And then we also debated on at least 3 examples of services that we think are coming in the short run. And there, of course, we do a work similar to the work that was done for the use cases, but for services, okay? Namely, debate on recommendations, how these services are expected to go, for instance, whether ad hoc will be present or not, and then specific communication KPIs. Next slide, please. So here you have an overview of the services that we collected and the sources. Even though that is not completely on the draft, we have a report, which later can be shared, okay, from a project, really explaining where the services come from, the different sources. Next slide, please. And so what you have on this slide is basically the collected information. Okay, so what did we collect? And so this, of course, goes for the regular reasons why we need wireless. That's quite important, okay, in particular with manufacturing. And then, so the regular KPIs, okay, latency, but also whether traffic is periodic or not, the cycles, if available, that we need, okay, to support the payload size, tolerance to packet loss, time synchronization needs, and whenever possible, also aspects such as node density per an area. Next slide, please. Okay, so then an example. Okay, so basically very simple example of an example of today. So I would say that we have a category. So what we dumped was not a use case. So it's not an equipment and process control use case. It's actually a category of services that we have there. Okay, and the services, for instance, control of machines and robots, or PLC, programmable logical controller to PLC communication. And so this to say that these are not use cases, okay? So they are services. And of course, we can integrate them into the use cases, but there's a distinction. Next slide, please. So on the second part of the draft, which relates with the future, but the near future, what you have are, again, 3 examples of potential, let's say, industrial services that require wireless, and what we think will happen. And for instance, of course, when we speak about industrial environments, most of the wireless infrastructure is still centralized. Okay, so it's infrastructure mode, but we believe the ad hoc part is necessary. And then if we go there, which aspects do we have to account for, and also try as much as possible to provide specific KPIs. Next slide, please. So in terms of next and last slide, okay. So basically, as said, what we have collected was a bunch of applications, and it would be great to grow this database, okay, and categorize them, provide specific KPIs. So as said, within merge or not merge, this is something that, so it's not a personal or individual perspective, okay. This is something that we have been asked often and often and often, and I'm doing a project, several projects on deterministic wireless, and then we have the same problem, which is, okay, but where are our KPIs, okay? And so the question, of course, for next steps is the regular one. This requires work. It's just the first version, okay? But the question is, okay, should we collaborate with the draft on use cases? And what I try to alert to on the mailing list is that, sure, but we would like, as far as possible, okay, if everybody agrees, to keep a more objective structure than just debating on the cases we have, and actually build, create KPIs and with specific sources. And again, alert that we are focused on services, not use cases. Of course, this can be merged because a use case has a bunch of services inside. But so adding a condensed version, I quite frankly don't know how that fits, okay? From the three authors, we discussed when we started this work, just to say that this actually, I've been in contact with Yves. It got delayed because of COVID and other stuff. So this is not from now. It's a document that we have been creating over the last year. And we did take a look into the use cases document, okay? And we decided to go ahead with an individual draft because we felt there was something missing, okay? I think I raised this discussion also a bunch of mails ago, okay? And despite the fact that I'm not active in RAW, I'm listening. So there are other reasons for in terms of time. So, but in other words, I'm open, and of course, this has to go to discussion and to merge the document. But so our idea was, okay, this is on the charter. Rick today said, okay, the charter is being redefined, but it is our belief that we need a document like this in the community and in RAW. Thank you.
Thank you, Ruta. I think this is a very useful and a very in-depth analysis. I think it's really helpful. So thank you. As I said to Carlos, the how we tie this with the use cases is very much open for debate. I agree with both of you. I don't want to lose this detail, and adding it all to use cases may unbalance the use cases document. Having it as a separate document, I think, is incredibly useful, but we need to be able to draw the two together in some way and cross-reference. Definitely a discussion for the mailing list, but yes, I personally, not with my chair hat on, I personally think this is a great document and we need to adopt it and make it work for us in terms of our grand scheme for how we're trying to make our documents make sense. As everyone keeps saying, for the fresh reader who comes along in 5 years' time, these things have got to be accessible and work out how to do it. But thank you very much to you and your team. That was really good.
Thank you.
Yes, and thank you for the detail. I wholeheartedly agree that this level of detail is immensely helpful.
I mean, go ahead, Abdusalam.
I agree also that we need to adopt actually the requirement document and this requirement document, and also the use case document. I'm not sure if we adopted already, but at least we discussed this so we can think in the future how about the technologies and the document already, the technology document. And regarding the DLEP and the MEC documents, maybe after we decide to adopt the requirement document and this document, or the use case document and this one, we can then think about other technologies or the MEC and the DLEP. And actually, I will add also that DLEP, in my opinion, is one of the technologies needed by networks, and so it can be included some information in the technology document regarding DLIP, how it's used or how it can be used with other technologies or something like that. And also, I will not forget that I thank Stan for the DLIP. He was the first author of this, and we forget because he passed away, you know. So we never forget he done a very perfect job on this document, and I have commented on it, and he was very nice. And I think also Rick knows that, and he's one of the important authors also. So DLIP, in my opinion, it will help a lot in this working group. So I hope also that Rick will do some, a draft or something like extension for this working group, because it's different from MANET. I'm one of the participants in MANET, but I think it's a different. And thank you very much.
It's a different use case. It's a different environment. Just to note, thank you, Abdusalam. Just to note, the use cases document is a working group document. So we have already adopted that. So
I want to thank everybody for their presentations, and I also want to thank whoever it is who's taking the notes, whose name does not appear on our list. Oh, I've been following the notes, and they've been extensive and wonderful. So whoever is taking those, could you please add your name or names to the top of our notes? We have a lot of terrific detail there, and we're at the top of the hour. So we're going to have to take some of this discussion to the mailing list, although we try to encourage discussion throughout. So thank you all for your participation. I'm almost awake at this hour.
On that note, I will add my thank yous as well. Thank you all very much. I think that was really useful. I will attempt to be in Gather.town. Normally I would be somewhere near a bar, but I shall have to be near a virtual bar. So I shall try and lurk there for the rest of the day, in and out of meetings. So please, if you've got questions or comments about RAW, I sometimes know what I'm talking about. I often don't, but I'm very happy to talk to you anyway. So you'll find me as Rick Taylor wandering around as a little ASCII art avatar. But otherwise, thank you very much. We will raise, I've made some notes on questions to take to the list. And as usual, if you think we've missed anything or you have any further comment, please use the list. We do all watch it. And thank you very much for participating.
And I would say, though, if you have some comments that have been in the chat that you would like to reemphasize, please do add those to the notes as well.
Yes. Yeah.
Many of them we've been trying to integrate, but please add there as well. It'll be open for quite some time, the notes.
Yes, this is a collaborative environment all round. That's all I can say.
So thank you.
Thank you all. I think we'll call it there, shall we, Eve?
Yes.
Yeah. Okay. Thank you all.
Enjoy the rest of the IETF.
And hopefully see you in person next time. Hopefully, COVID willing.
In San Francisco.
Yeah, hopefully. Okay.
I think. Bye.
Yeah. Bye all. I don't know how we close this meeting. I shall just quit, I suppose.
I think we just leave individually.
I think we just leave. I'm going to turn my video off. Goodbye. Thanks, Eve. I'll catch you later on.
Thank you, Rick.